Here is our second and final example for 2.5 day 2. The last example was about factoring out completely a polynomial with imaginary zeros and real zeros, and we went into great detail with that one. So as long and annoying as that process was, this one's going to be a lot nicer. It just adds in a concept that we haven't really talked about yet, and that's irreducible quadratic factors. So what we're going to do is we're going to write the factorization of this polynomial here, but we're going to stop when we get to something called an irreducible quadratic. Now, an irreducible quadratic is just one that is not able to factor in a nice way. So it doesn't have nice integer coefficients or real numbers if we were to try to factor it further. So we're going to break it down until we get to that point, and then we're just going to stop. And so it'll be a little bit nicer as far as this process goes. Now, one thing you need to do at the beginning here is just think of this as the 6-step process and just start going through, and we'll eventually stop, but we'll start the way we usually do. 6 has factors of 1, 2, 3, and 6. The reason I'm talking about that is because we need to know our plus minus list. X cubed, that's just a 1 in front of there, so that's the only factor there is just a 1, so we don't have to worry about fractions. It's just going to be 1 over 1, 2 over 1, 3 over 1, 6 over 1. So we'll call our list here just plus minus 1, 2, 3, and 6. Those are our possible rational zeros of this function. We graph it to kind of narrow it down. Looks like from the graph it's crossing over. It appears to be positive 2. As I've mentioned before, we need to verify this. That's where the synthetic division comes in. We need to verify that this is actually the case. Plus, in this problem, our main goal is to factor, and so if we divide that out using synthetic division, then we'll have broken it down a step and we'll have created a factorization there. So we're going to take synthetic division, enter our coefficients in there. Looks like we've got 1x cubed, negative 1x squared, 1x, and minus 6. Our k value is the same as our 0, so that's a 2 on the outside. And then we go through our process of normal synthetic division, bring the 1 down, multiply by 2, add those together, multiply by 2, add them together, multiply by 2, and like we're hoping to see at the end, there's a 0, which means that this actually is a factor. We can pull that out, and we're left with 1, 1, 3, which remember is not the answer, but it represents the polynomial x squared plus x plus 3. Now at this point, here's where we get to the irreducible quadratic. You're going to get to somewhere you might wonder if they're factorable. Try a couple of different factorizations, see if you can get something to work, and if you can't, graph it, see if it crosses anywhere. Most likely in this case it's not going to factor, and so we use that as an irreducible quadratic. Now the other factor that we have from this original is just this 2, so it's x minus 2. So in this problem we're simply getting to the point where we have a factorization where it's a linear factor, that's this one, and irreducible quadratic, that's right here. We're going to stop at this point because that's the factorization that it's looking for. If we wanted to go further and split this up, we could use the quadratic formula, but we would inevitably get imaginary solutions or really nasty irrational solutions or factors, and so we're going to leave it at that whenever it says to write it as irreducible quadratic factors.